It uses asymmetric cryptography in which information can be shared using a public key. Primary keys are linked to users, providing digital signatures a quality of non-repudiation. Now, let's take a look at how these digital signatures are created. Digital signature creation. The signer takes the information to be transmitted and runs a hash algorithm in order to generate 32 or 64-bit hash value. This hash value is then encrypted using the signer's private key. The result is a digitally signed document, which is broadcasted into the network. Once the verifier receives this digitally signed document, he decrypts the same using the signer's public key. The hash value created after decryption is then compared with another hash value locally generated by the verifier using the same hash algorithm as the one used by the signer. If the hash values are equal, then the signature is considered valid and the verifier can then use the document. Generation of a public-private key and a digital signature. Let's have a look at the first demo of today's session. We are going to take help of this open and interactive website by Anders for this demo. Okay, let's get started. As a very first thing, you need to visit the link https://anders.com/blockchain/public-private-keys/keys.html. Once you are in there, click random to generate public and private keys. There you have your private key and the public key displayed in the respective fields. All right, next we're going to see the signatures. For that, you must click Signature tab from the top menu pane. Now enter a message in the message field. For example, "Hi, welcome to Simply Learn," and click Sign button. You will see that a digital signature is created, which contains the hash of the given message. Okay, now visit the Verify tab and click Verify button to verify the digital signature. The screen turns green if the digital signature and the message is authenticated. Change the message in the Message tab and click on Verify. You will see that the screen turns red, symbolizing that the message or the digital signature is incorrect. All right, that's all for this demo. We saw how to generate the keys and the signature and how to verify it. Let's take a recap of the steps I have followed. Step 1, visit the link https://anders.com/blockchain/.html. Step 2, click on random to generate public and private keys. Step 3, click Signatures tab. Step 4, enter a message in the message field and click on Sign button. Step 5, visit the Verify tab and click on Verify button to verify the digital signature. The screen turns green if the digital signature and the message is authenticated. Step 6, change the message in the Message tab and click on Verify. You will see that the screen turns red, symbolizing that the message or the digital signature is incorrect. Transaction broadcast. Features of blockchain. A decentralized network is a system where miners play an important role in the validation of transactions taking place. Before I tell you more about decentralized network, let me tell you about the types of networks. Types of network. There are two kinds of networks, decentralized network and centralized network. Blockchain is built on a decentralized network, which can be identified by peer-to-peer connections of miners who play an important role in the validation of every transaction. This is the most striking aspect of blockchain technology. It eliminates the need for central authorities to govern the network. Instead, the entire control is in the hands of the individual users. Decentralization makes the entire system fair and secure. The other kind of network is a centralized network. Centralized network can be identified by a mandatory centralized point, which can be a client, a hub, or a piece of hardware through which all data on the network must pass. The current structure of the internet is the best example of centralized networks. Features of consensus. Features of blockchain. A consensus algorithm is defined as a concept from computer science which is utilized to reach an agreement on a specific data value when the system is distributed. Thus, consensus algorithms provide reliability in a network comprising of unreliable nodes. Consensus protocol. A consensus protocol is a fault-tolerant protocol that is used to achieve the necessary agreement on a single data value or a single state of network. Fault tolerance is defined as the ability of a system to continue operating normally in the event when some of its components